We're going to talk about quantum numbers. Quantum numbers are a set of 4 values that describe the energy of the atom's electrons. So every electron in an atom has its own set of quantum numbers. The first one is principal quantum number, and the symbol for that is N. And the principal quantum number describes the orbital size and the energy level. And the principal quantum number has values of 1, 2, 3, so on and so on. The secondary quantum number, L, describes the orbital shape of the sublevels or the subshells. And those values range from 0 to one number less than the principal quantum number. The magnetic quantum number has the symbol ML, and that describes the orbital orientation in space, and it has values of negative L to positive L. The spin quantum number, it describes the electron spin direction, and the symbol is MS, and if the electron is spinning upward, that would be a positive 1/2, and if the electron is spinning downward, that would be a negative 1/2. Let's take a look at an example. Describe the quantum numbers for each of the electrons of oxygen. We have to do a few things before we can actually describe the quantum number. We have to start off with the electron configuration. Oxygen has atomic number 8, so the electron configuration for oxygen would be 1s2, 2s2, 2p4. The next thing we want to do is draw the orbital diagram for every single electron. So the orbital diagram, 1s has 2 electrons, one spinning up, one spinning down. It has 2 electrons in 2s, one spinning up, one spinning down. P has 3 orbitals, and there are 4 electrons. We have to let them spin upward and alone before we start pairing them up. So 1, 2, 3, 4. So I've done the electron configuration and I've drawn out the orbital diagram. Now I can start describing the quantum numbers. Remember, we're trying to find a set of 4 values for every single electron. So in subshell 1s, there are 2 electrons. And the quantum number N is going to be this whole number, 1. N is 2. It's always going to be the whole number. So in 1s, I have principal quantum number 1, 1. And for the L, that describes the shape. If we can just remember that there is the S shape, the P shape, the D shape, and the F shape. And the quantum numbers for those for L is going to be L equals 0, L equals 1, L equals 2, and L equals 3. So 1s, S is the shape, and there are 2 electrons. That means L has to equal 0. And the ML is the space of the electrons, how they are orientated in space. There's only one subshell, so they are, you can think of it on the 0 on the axis. We have 1 electron spinning upward. So for the MS, we have to say positive 1/2 for that electron, and then 1 electron going downward. That would be the negative 1/2. We have to do this for every single electron. So now we do the 2s. The 2s is the orbital name. There are 2 electrons in 2s, so the quantum number for that is 2. And S has the shape of 0. And there's only 1 orbital in 2s, and that's at the 0 axis. 1 electron is spinning upward, and 1 electron is spinning downward. Now let's talk about the 2p electrons. There are 1, 2, 3, 4 electrons in 2p, and the quantum number for the principal quantum number is going to be 2. And they are in the p shape. The L for p is 1. Now we have to think about how they're orientated in space. The best way to think about this is the number line. The first subshell is going to be -1, 0, then +1. Think of it as the number line. So the first electron that's spinning upward is going to be an ml equals -1 and is spinning upward, so that's +1/2. The second electron is in when ml equals 0, it's spinning upward, so that's +1/2. The third electron is in +1 and is spinning upward. And that fourth electron comes back to -1, but is spinning downward, so we have to say -1/2. So we've described the quantum numbers for every single electron in oxygen. Let's take a look at another example. Describe the quantum numbers for each of the electrons of sodium. Sodium has atomic number 11, so we're going to do electron configuration for sodium. 1s2, 2s2, 2p6, 3s1. Now we're going to draw the orbital diagram for all of the electrons. 2s has 2 electrons. Remember that p has 3 orbitals. 1, 2, 3, 4, 5, 6. And there's 1 electron and at 3s. Now I want to describe the quantum numbers. I'm going to describe the 1s first. In 1s, the quantum number is 1, 1. The principal quantum number is the whole number. And s has to have a shape. Let me remind myself. There are the shapes S, P, D, F. And that means L equals 0 for S, 1 for P, 2 for D, and 3 for F. So we're in the shape S, so that means L has to equal to 0. There's only 1 subshell, so that would be 0. 1 electron spins upward, that's a +1/2, and 1 electron spins downward, that's a -1/2. We also have the electrons in 2s. The principal quantum number for 2s is going to be 2. There's only 1 subshell, so we can go ahead and put the shape for our 2s is S, which means L is 0. And there's only 1 subshell, so that means 0. And 1 electron spins upward, 1 electron spins downward. Now let's talk about the P. There are a total of 6 electrons in P. The principal quantum number is 2. The shape is P, so that means 1. And now let's describe every single electron. There is 3 subshells, so we're going to give it the assignment -1, 0, 1. So the first electron is in the ml equals -1, and it spins upward. The second electron is in 0, it spins upward. The third electron is in +1, it spins upward. The fourth electron comes back to -1, but it spins downward, so it's -1/2. The fifth electron is in 0, it spins down. And the sixth electron is in 1, and it spins down. Then we have the 3s electrons. There's only one electron in 3s. The principal quantum number is 3. It has the shape as s, so we say 0. It's in only one subshell, so we say 0. And it spins up, so we say positive 1/2. Good luck and keep practicing.